Hello, everyone. Let me introduce my project and thank you for paying attention to our presentation. Our team is Ceci, Mariana, Juan, Felipe, Nicolas, and Pablo. I want to talk to you about ISA. ISA is the line transmission company, electricity transmission in Colombia. It's on charge of mostly 90% of the total market of energy in Colombia and is the source of the energy in the whole country. However, as you may know, lightning strikes can cause several damages on on the transmission lines, and that's why it's very important to understand whether we can predict and prevent that these strikes hit the transmission line. Next, I want to show you some of the problems that we might encounter. For example, problems with the industry in production process, computers, internet, traffic lights. We have problems in the medical and in the healthcare industry, which are really critical for the country, and that's why we choose this project and its impact. However, it's important to know like there is not a lot of data that is captured to predict. Some is of course to have the lightning strikes and how those affect the transmission lines. For example, here you can see clusters that are affecting the transmission line, clusters of lightning strikes that are hitting the ground close. Some are close, some are farther, but the most important thing is like these are the causes that hit and make the failure and cause the failure in the transmission line. And we wanted to predict whether these clusters plus some additional data that we got can cause a failure. The other additional data, as you can see in the next slide, is related to the weather. No, it's not only the lightning strikes that are causing failures, but it's also the conditions on each of the towers along the transmission line. So part of the project was also we wanted to include weather data and weather data that we can collect online. Some sources that we use, NASA, Open Weather, and satellite information was very useful for this. So let's go to the model. First, we split the model. The first one is related to the probability to have a failure along the transmission line. And the second one is related to where this failure is going to be happening. The next model is related to exactly to that, because where we can know if this is going to happen in the farthest part of the transmission line, or maybe in the south, or maybe in the west. So we didn't know. So that's why we created these two models. So let's go to the platform.
Okay, thank you, Juan, for introducing our project. Now I'm going to present you the web application that we developed in order to allow the users of ISA to control and better understand how these variables can affect the transmission lines. So the web application lands on the analytics page. This page is designed for control and monitor all of the weather and climate variables that we are pulling from Open Weather, which is a live source of information. So let me walk you through this page. Basically, here at the top, you will find the most important variables that could affect the behavior of a transmission line. So in order to make the information appear here at the top, you can go here to the map, zoom into the map and select a tower, and all the information will be displayed here on each one of the cards. Here you can see the temperature, pressure, humidity, dew point, clouds, and wind speed. Of course, you can also select another line that you're interested in, and all the information of that line will appear. If I select another tower, here you can see the description of that tower, weather at this particular point of time, and also the latitude and longitude of that tower. Also, if you ever have any question, you can hover over this info and you will find a short help that will guide you through this web application. So if you keep scrolling down, you will find the time series analysis. So here you will find the pressure analysis, temperature analysis over the time for each one of the lines that you have selected here before. So this is very valuable for analysis. Also, you can see here, if you go up here and select multiple variables, you will find that it is also very valuable to see these correlation metrics that allows you to interpret how these variables are correlated. So here you can go deeper into your analysis. Now, moving on to the dashboard page, here we have implemented an overview and a general view of the failures and how the lightning strikes are behaving the 2 hours before that failure happened. So here you can select any of the failures that we have in the database, and all the information will be filtered by that failure. Here you can see the information of all the failures. So yes, you can see here that information by the current or the magnitude. Moving on to the maps tab, here you can see, and the idea of this tab is to perform a geographical analysis through all the variables that we are interested in. So here at the top, you can see the discharges within 5 kilometers, and here we can see how these discharges are spread through the territory. If we keep scrolling down here, you can select which variable you want to analyze, and notice that this variable will be displayed here to the left in the line that you have selected here at the top. And you also can select the date that you want with the hour that you want, and all the information will be displayed. Here you can see the description of the weather at that particular point of time. Now, if we move to the line status page, here we can see this tab that is representing the output of the second model. So basically here, what you can see is the lightning strike probability at a particular tower location. So here, the idea for the user is to select any tower that he wants and see how is the probability of a lightning strike to happen at this particular location. So if you keep selecting the towers, you can see here at the left how this gauge is moving based on the location. So here we can see a lower probability of a lightning strike. And what is important to notice about this tab is that all the data is live data. So it is important to notice that, because this behavior is basically happening all in real time. Now, here at the failure prediction tab, we can see how the user can manipulate this user interface to drag and drop the files of the recent lightning strikes. So let me make you a demo.
Nico, I want to explain there that this model, it's a complement of the one that you show and we can see in the previous tab. So what happened with these two models, and as Nico is showing here, is that we need information of the lightning strikes, and we need this information to happen live, which is going to complement the weather information. The weather information, which Nicolas showed in the last tab, is related to the geography, and this model is related to how lightning strikes will cause the failure. But this model complement the other, because we need to know when it's going to happen and where it's going to happen. As you can see here, the file that Nico uploaded, he just created an easy interface to understand which data can I pull up into the model. So I can have the lightning strikes here, plus the weather data that is currently fit, and then run two more features. One is going to be the bottom, building the features, collecting of this data into one single platform. And the second one is the actual model, is the one that is going to take both models and calculate the probability. The probability is at the level of 5 minutes intervals. And as you can see here, for example, for the next 5 minutes of this time of the data, it's almost 70%. So where you want to take a decision of, okay, a failure, it's complicated if the probability for the next 5 minutes hits 80% or 90% or 95%. With this number, you can have and prepare, and you can be ready for that moment. And with the previous tab plus this number, you know where exactly is going to happen. So these two models as a beautiful complement of how the clusters and geographic data is happening, and is helping us to prevent failures along the transmission lines in more than 7 to 20 departments in Colombia. So both models create the best combinations to know where and how can I be ready for the failure. Thank you. Thank you so much. Thank you,